What's the real cost of 8.7 seconds? For 8 people racing across the Caribbean at 47 knots, it was everything. For a Marine Corps pilot tracking them from 12 miles away, it was just another mission. And for a single Hellfire missile costing $148,000, it was exactly enough time to teach the most expensive lesson in naval interdiction history. This is the story of what happens when desperation meets overwhelming technological superiority. When human decision-making collides with systems that think 50 times per second. When 8 smugglers made a bet that speed would save them, and discovered they were wrong by exactly 8.7 seconds. By the end of this video, you'll understand why the US military doesn't chase boats anymore. They simply delete them. And why this 10-minute incident represents the future of maritime security, whether we like it or not. But first, you need to understand what was actually at stake. October 2024, the so-called Fast Lane, a 600-mile corridor between Venezuela and Puerto Rico that's become the express route for maritime smuggling operations. Over $2 billion in illicit cargo transits these waters annually, and the U.S. Southern Command has made it clear. These aren't international waters where everyone plays nice. They're a chessboard where one side has satellites and the other side has hope. On this particular morning, 8 individuals made a choice. Whether driven by poverty, coercion, or profit, we'll never know. What we do know is they climbed aboard a 35-foot go-fast boat equipped with twin Mercury 300 horsepower outboards and pointed north at maximum throttle. Their cargo? Unknown. Their destination? Irrelevant. Their odds? About to become zero. Because 17 minutes earlier, at exactly 0946 hours, a radar operator on a Boeing P-8 Poseidon surveillance aircraft at 22,000 feet had flagged their signature: dual engines, northbound trajectory from cartel territory, speed consistent with smuggling operations. And the moment that digital flag went up, 8 people went from civilians in a boat to designated target in the world's most sophisticated interdiction network. They had 13 minutes left. They just didn't know it yet. Let's talk about what asymmetric really means in modern warfare. On one side, a fiberglass boat worth maybe $80,000. 2 outboard motors running slightly out of sync because maintenance schedules and criminal enterprises don't exactly align. 8 human beings whose life choices or circumstances put them on this trajectory. No armor, no countermeasures, no defensive systems. Their only advantage? Speed, 47 knots. That's 54 miles per hour on water, which feels incredibly fast when you're the one holding the throttle. Now let's talk about what was hunting them. The AH-1Z Viper. Let me paint you a picture of what $31 million in attack helicopter engineering looks like. This isn't just an aircraft. It's a flying sensor platform with anger management issues. 2 General Electric T700 turboshaft engines producing 1,800 horsepower each. 4-blade composite rotor system. Maximum speed, 222 miles per hour. Combat radius, 370 miles. But the real magic isn't in the airframe. It's in what's hanging off it. 8 AGM-114R Hellfire missiles mounted on stubwing pylons. Let me break down what $150,000 buys you in precision-guided munitions. Weight, 108 pounds. Length, 64 inches. Warhead, 20 pounds of multi-purpose explosive that doesn't care if your target is a tank, a building, or a boat. Maximum range, 8 kilometers. Maximum speed, Mach 1.3. That's 995 miles per hour. But here's what makes it terrifying. It doesn't aim where you are. It calculates where you'll be. 50 times per second. Every 20 milliseconds, solving navigation equations that would take a human mathematician hours. You're not racing a missile. You're racing math. And math doesn't get tired. Overhead at 22,000 feet, a P-8 Poseidon maritime patrol aircraft that started life as a Boeing 737 passenger jet. Same airframe you've flown on vacation. Except instead of drink carts and Wi-Fi routers, this one carries $420 million in surveillance equipment. The AN/APY-10 radar system can track a volleyball from 20 miles away. Its acoustic sensors, sonobuoys dropped into the water, were literally listening to the engine noise of those Mercury outboards. They could tell the engines were slightly out of sync. They knew the approximate fuel level based on exhaust temperature. They'd probably calculated wave height, water temperature, and the boat's estimated structural fatigue. And that information was being fed in real time through Link 16 tactical data network to every U.S. asset in the region. including the helicopter pilot who just received authorization 13 minutes ago. 6 years flying attack helicopters, 0 missed targets, perfect operational record. Currently cruising at 155 knots toward an interception point his computer calculated before the boat crew even realized they were being tracked. His visor, a $200,000 piece of headgear called the Top Owl Helmet Display System, was projecting every relevant piece of data directly onto his field of vision: distance, closure rate, wind speed, target velocity, optimal firing solution. He didn't need to look at instruments, he just needed to look at the target, and the helmet did the rest. Think Iron Man, but real, and taxpayer-funded. 1,003 hours. The Viper had closed to within 19 nautical miles. In the boat, they're probably feeling confident. Open water, no Coast Guard vessels visible, just blue sky and the roar of those Mercury engines screaming at full throttle. They don't know that 12 miles behind them, a helicopter is matching their course. They can't hear it over their engines. They can't see it because it's staying low, below their horizon line. And they definitely don't know that a P-8 overhead has already calculated their fuel range, predicted their destination, and determined that interception before Venezuelan territorial waters is operationally feasible. The pilot activated his targeting system, an invisible laser, 20 milliwatts at 1.064 micron wavelength, painted their boat. To human eyes, nothing. To the Hellfire's seeker head, a giant neon arrow saying "Free Buffet." And here's where it gets interesting. The boat started taking evasive action. Wait, how did they know? Maybe someone spotted the helicopter's rotor glint. Maybe they had a radio tip-off. Maybe pure instinct. Whatever the reason, they started a defensive pattern. 45-degree turns every 30 seconds. Serpentine maneuvers, the kind of evasive action that works great against human reaction times. But the Top Owl helmet system wasn't relying on human reaction times. The pilot's head movements, tracked by electromagnetic sensors, controlled the FLIR turret beneath the helicopter's nose. When he looked at the boat, the laser stayed locked on target. When the boat zigged left, predictive algorithms anticipated the movement before it happened. The boat's evasive maneuvers were being calculated and compensated for 60 times per second. You can't dodge a computer. You can only tire yourself out trying. The pilot was setting parameters: target type, surface vessel, engagement mode, lock on before launch, attack profile, direct attack, horizontal trajectory for waterline impact, fuse setting, instantaneous detonation on contact. Every setting optimized for one outcome: maximum flooding, minimum floating, 0 survivors of the vessel. While this was happening, inside the selected Hellfire, systems were warming up. The seeker head cooled to -200 degrees Celsius using compressed argon gas. Extreme cold reduces thermal noise, allowing it to see the faintest laser reflections through its germanium lens. The ring laser gyroscope spun up to 40,000 rotations per minute. The missile's internal computer ran diagnostics on 147 separate systems in under 1 second. All green. This weapon was ready. Range: 5.5 kilometers. Optimal. The Hellfire can reach 8 kilometers, but 5.5 delivers maximum kinetic energy on arrival. Then came the words through the pilot's headset. Viper 21. Weapons free. You are cleared hot. Military translation: you have permission to expedite some international maritime policy. At 10:09 hours, the pilot squeezed the trigger. The next 8.7 seconds would become a textbook example of modern precision strike capabilities. The Hellfire missile left the rail. Solid rocket motor ignited. 500 pounds of thrust. 0 to Mach 1.3 in 2.5 seconds. That's 20 G-forces of acceleration, enough to turn watermelon into smoothie. But the missile's electronics were built for exactly this abuse. The autopilot took control immediately. In the first millisecond, it processed. Laser bearing 186 degrees. Target depression angle 12 degrees. Current altitude 2,000 feet. Current velocity, Mach 1.1. Distance to target 5,100 meters. Calculation: climb to build energy. Then terminal dive for optimal impact geometry. The missile arced upward to 2,500 feet, trading speed for altitude like a roller coaster climbing before the drop. Canard control fins at the front made microscopic adjustments. A fraction of a degree here, half a degree there. Every movement calculated to maintain the perfect ballistic trajectory. Meanwhile, the rocket motor consumed composite propellant at 12 pounds per second, generating 5,000 degrees Fahrenheit inside the combustion chamber. The missile's skin temperature climbed to 900 degrees from atmospheric friction alone. Then it nosed over. 35-degree dive. Gravity joined the party, re-accelerating the missile back through Mach 1. Inside the warhead, the FMU-139 intelligent fuse armed, not a simple impact switch, a smart device monitoring multiple sensors, configured for instantaneous contact. It would trigger the microsecond the crush sensor detected impact. The seeker head never lost that laser sparkle. As altitude decreased, the reflection evolved from a point of light to a defined shape, 5 seconds to impact. The guidance computer resolved the actual outline of the boat. 3 seconds. Control fins locked into terminal approach configuration. 1 second. Final image capture. A white hull expanding rapidly in the field of view. In those final seconds, did anyone look up? Did anyone see it coming? At 995 miles per hour, probably not. The human eye can track objects at maybe 60 degrees per second. This was arriving at over 6,000 degrees per second of angular velocity. One moment, open sky. Next moment, physics education delivered at supersonic speed. The crush sensor triggered. The FMU-139 sent detonation command in 1,000th of a second. 20 pounds of multi-purpose warhead released energy equivalent to 18 pounds of TNT. Overpressure at ground zero, 200 psi, enough to shred steel. Fiberglass hull provided resistance comparable to tissue paper in a hurricane. The Top Owl thermal sight recorded everything. Initial detonation created a white-hot bloom that maxed out the infrared sensors for a full second. Then, the debris field resolved. A perfect 100-meter circle of what used to be a boat. Larger components, engine fragments, pieces of hull, splashed down first. Smaller debris rained down for the next 30 seconds like the world's most expensive confetti. Viper 21, good effect on target. Vessel destroyed. The pilot's report, calm, professional. The tone of someone who just converted a smuggling operation into a maritime lesson. Let's talk about what actually happened here. Complete engagement time, 8.7 seconds from launch to impact. Less time than it takes to order coffee at Starbucks. The boat traveled approximately 570 feet during that time. The helicopter traveled 0 feet. It stayed on station, 12 miles away. Cost breakdown. $148,000 missile versus an $80,000 boat carrying cargo of unknown value. From a pure economic standpoint, this seems inefficient. But here's what those numbers don't capture. This wasn't about one boat. It was about every boat watching, every cartel operator calculating their odds, every smuggler wondering if speed really matters when you're racing satellites. The helicopter returned to USS Wasp 19 minutes later, landed, refueled, ready for the next mission. The pilot debriefed, wrote his report, went to lunch, another day at the office. For 8 people in that boat, it was the last calculation they ever made. So why am I telling you this story? Because this is the new normal in maritime interdiction. No warning shots, no radio negotiations, no high-speed chases with Coast Guard vessels playing catch-up. Just detection, tracking, calculation, and consequence. Some will call this efficient, others will call it excessive. The truth lives somewhere uncomfortable between those two extremes. Here's what's not debatable. Technology has fundamentally changed the equation. When one side has satellites, predictive algorithms, and precision weapons, and the other side has speed and hope, the outcome isn't really in question. The question is, what happens to deterrence when the barrier between detection and destruction is 8.7 seconds? Do faster boats even make sense anymore? Or is this entire approach obsolete, replaced by systems that think 50 times per second and don't negotiate? And here's the really uncomfortable question. How many of these incidents happen that we never hear about? How many successful interdictions are statistical entries in a database somewhere with no names, no faces, no families asking questions? Technology makes warfare precise, but precision doesn't make it clean. This helicopter strike was textbook perfect, by the book, legal under international maritime law, operationally flawless, and 8 people still died in 8.7 seconds. That's the cost of modern warfare, measured in milliseconds, calculated by computers, executed by professionals, and forgotten by everyone except the people who mattered most. So here's where I need you to engage, because this story isn't just about military technology, it's about what we accept as normal, what we justify, what we look away from. 3 questions for the comments. First, where's the line between legitimate interdiction and disproportionate force? 8 people, 1 missile, 8.7 seconds. Is that the new standard? Should it be? Second, if you were designing maritime security policy, how would you balance deterrence against humanity? Is there a version of this story where those 8 people face trial instead of becoming debris? Third, what would you have done in that cockpit? Orders received, target locked, trigger ready. It's easy to judge from behind a screen. Harder when you're the one wearing the helmet. Drop your honest answer in the comments. Don't give me what sounds right. Give me what you actually think. If this story made you think differently about modern warfare, even for just a moment, hit that subscribe button. This channel exists to show you the uncomfortable truths behind military operations, the ones that don't make recruitment videos. That video drops Friday. Don't miss it. And if you made it this far, comment 8.7 seconds so I know you watched until the end. The algorithm doesn't care about watch time unless you interact, so prove you were here. Until next time, remember, in modern warfare, speed doesn't save you, distance doesn't hide you, and luck doesn't even factor into the equation anymore. Stay curious, stay critical, and never stop asking the hard questions.